Okay, in this video we are going to do a lot of chain rule problems, and there's a link to the problems in the description, and my thought is that you will look at the problem and try it and then watch, or watch and then pause and then try it on your own. Alright, so it's probably going to be a long video because we're going to do a lot of problems. Let's get started. First problem, we have y equals the quantity 5x plus 6 to the fifth, and we want to find the derivative of this thing. So this is a composition, and that means we're going to use the chain rule. What I'm going to do for most of the problems in the video, maybe all of them, is I'm going to kind of colorize things so that you can see like the different functions involved. So big outer function is something to the fifth, the inner function is 5x plus 6. So the first thing I want to do is find the derivative of big outer function. So the derivative of something to the fifth is 5, that thing, and then to the fourth. And then what's that thing? It's 5x plus 6. So that inner function can't change, it's always just going to stay the same. So we have 5, the quantity, 5x plus 6 to the fourth. Then we need to multiply by the derivative of the inner function. So the derivative of 5x plus 6 is 5. And then that's the end, and we just want to kind of simplify this. So we get y prime is 25, the quantity 5x plus 6 to the fourth. All right, let's do another one. So we have y is equal to the quantity x cubed plus 3x plus 2 to the 12th. So we have two different functions involved, so let's colorize them, or color code them, I guess. So we have this. All right, so to find the derivative, first I need the derivative of the big outer function, which is something to the 12th. So the derivative of something to the 12th is 12 times that thing, and then to the 11th power. So we bring the exponent down, subtract 1, that's just the power rule basically. Then, because it's a composition, I need to multiply by the derivative of the inner function. So the derivative of x cubed plus 3x plus 2 is the quantity 3x squared plus 3. And then I want to clean this up. So if you look at it, 3x squared plus 3 actually has a 3 in it that I can factor out. So that 3 times that 12 gives me y prime is 36. And then I took 3 out of 3x squared plus 3, so I only have x squared plus 1. And then this other thing I'm just going to carry through. And so this is our derivative. All right, let's try another one. So we have y is equal to the quantity 8x plus 1 to the fifth. All right, so I'm going to color code everything. Now I need to find the derivative. So what I'm going to do is start to do them in a slightly more sophisticated way, basically just skipping steps. I know that I'm going to have to take the derivative of something to the fifth, so that'll be 5 times that thing to the fourth, and then I need to multiply by the derivative of the inner thing, so really I'm going to end up with this 5 is going to be a part of the coefficient, and then the derivative of 8x plus 1 is just 8, so I'm going to end up with 5 times 8, I'm just going to write 40, and then I just have the quantity 8x plus 1 raised to the fourth power because I used the power rule. So that's how I actually end up doing these most of the time, so I'm going to start doing them more that way as the video goes on. Let's move on to a fourth problem. Okay, so we have y is equal to the quantity 23x squared plus 4 to the second power. Let's color code it. Although at this point, hopefully you're starting to see you don't really need to color code these, but it's still really helpful, so I'm going to do it throughout the video. So our derivative, y prime, is going to involve a power rule that brings that 2 down, and then multiplied by the derivative of the inner function. So the derivative of 23x squared plus 4 is really just the derivative of 23x squared because the derivative of 4 is 0. So I'm going to bring a 2 down, and I'm going to end up multiplying it by the derivative of 23x squared, which is 46x. So the coefficient kind of here is going to be 46x times 2. So y prime, I'm going to have a 92x because that's 46x times 2, and then times the quantity 23x squared plus 4 to the first power. So what I did was I brought the 2 down, the thing to the first power, and then times the derivative of the thing. The derivative of the thing was 46x, so 2 times 46, 92 rather, x, and then the quantity 23x squared plus 4. So it's like harder to talk about than it is to do. Let's do a problem that will involve something a little more complicated. All right, so problem number 5 here. We have y is equal to the quantity 3x plus 5 to the fifth times the quantity 4x minus 3 to the fourth. All right, so that's actually a product, so I'm going to use a product rule, and while using the product rule, I'm going to use a chain rule. So most problems involving the chain rule really are like just general derivatives, any rules up for grabs. Let's color code this thing. So here we have one composition, and then we have a second composition. So I tried to use a second color. It's just like a darker version. All right, so product rule. Y prime is the first, so nothing changes here. And then for the derivative of the second, I need to use the chain rule. So I'm going to bring a 4 down because of the exponent, the power rule. So bring 4 down, and then times the derivative of the inner function, which is actually just 4. So 4 times 4 is 16, quantity 4x minus 3 to the third. So really it's working out that coefficient that's the biggest deal, because you know that you're just basically using the power rule at this point. So you knew that like the 4 would go to a 3 in the exponent. Plus second, so nothing changes there. And then derivative of the first. So same idea. I bring a 5 down from the power rule. I multiply by a 3 because of the derivative of the inner function. So that's 5 times 3 is 15. Quantity 3x plus 5 to the fourth because we're using the power rule. And now when you do these sorts of things with a product that involves chain rules and polynomials, I guess binomials to powers, whatever, these things, you end up factoring a lot. And what's nice about it is you just kind of like look through for the common things. So I have 3x plus 5 raised to 2 different powers. The smallest of the powers is 4, so I'm going to factor that out. 3x plus 5 to the fourth. I have 4x minus 3 raised to 2 different powers. The smallest power is 3, so I'm going to factor that out. And then let's see what we're left with. So here, definitely 16. We still have a 3x plus 5. So quantity 3x plus 5. We still have this plus. There's still a 15. So I'm looking at that second term thing there. There's still a 15. And then we took out 3x plus 5 to the fourth. We still have a quantity 4x minus 3. Okay. And now you just kind of expand that third set of parentheses. You don't want to expand the first two. That would be that'd just be annoying, really. There's no reason to do that. So ultimately, you end up with this when all is said and done. All right. So what I'm going to do is another problem. Basically the same type of problem. So we have y is equal to the quantity 2x minus 7 to the 12th times the quantity 3x minus 1 to the 17th. All right, so let's do it. It's going to be a product rule, and while doing the product rule, we need to use the chain rule a lot. So y prime is first, 2x minus 7 to the 12th. Derivative of the second is going to be, so we're going to bring down 17 by the power rule. We're going to multiply by 3 by the chain rule, so 17 times 3 is 51. Then we're left with the quantity 3x minus 1. We use the power rule, so we reduce by 1 to get 16. Plus, because we're using the product rule, the second, which is 3x minus 1 to the 17th, times the derivative of the first, which involves the chain rule. So we're going to bring down the 12 by the power rule, but we're going to end up multiplying by a 2 because we need the derivative of the inner function. So we got 12 times 2 is 24. The quantity 2x minus 7 to the 11th because we subtract 1 from the exponent. And at this point, it's just like the previous problem where we want to look through and factor out anything we can. So it turns out in this case, 51 and 24 are both multiples of 3. So the first thing I can do is I'm going to factor out, a 3. And so we have 2x minus 7 to the 12th and 2x minus 7 to the 11th. That we take out the smaller power. So 2x minus 7 to the 11th. 3x minus 1 to the 16th and to the 17th, so we take out 3x minus 1 to the 16th. So then we look and see what are we left with. Well, we took a 3 out of 51, so we're left with a 17 there. We took out everything except a 2x minus 7. Then we have a plus. We took a 3 out of 24, so we're left with 8. And then we took out everything except a 3x minus 1. Okay, and then what you do is you just expand that third set of parentheses again, and ultimately you're going to end up with this. All right, the next problem is kind of similar. It still involves a chain rule, but we're going to use it's a quotient, so we're going to use quotient rule. So let's do that. So y prime is going to be bottom, so 6x plus 1 to the 7th. Derivative of the top involves a chain rule, so bring down the 15 by the power rule, multiply by 3 because it's the derivative of the inner function, so 15 times 3 is 45, and then quantity 3x minus 4 to the 14th, because we subtract 1 from the exponent, and then it's quotient rule, so that's bottom derivative of the top minus top derivative of the bottom all over the bottom squared, so we're going to have a minus, and it's so it's bottom derivative of the top minus top, so 3x minus 4 to the 15th, derivative of the bottom, so we're going to have a 7 by the power rule, a 6 by the chain rule, 7 times 6, so 42, quantity 6x plus 1 to the 6th. If you're actually in my class and I taught you the quotient rule, at some point I probably told you never to stop and talk in the middle of it and just like finish the problem, then go back to your conversation, and you can see if you mess that up, it just gets a lot harder on you. And then let's see. It's like a PSA in the middle of doing it. PSA to not do what I'm doing. All over the bottom squared. So quantity 6x plus 1 to the 14th. All right. So these sorts of problems, there's a lot of factoring in the numerator, just like when you deal with a product rule. And then the denominator will almost always, well, it actually will always, for this type of problem specifically, cancel with something in the numerator. So let's see, because you can just see there's a lot of 6x plus 1s hanging around. But first, let's just deal with the numerator. So 45 and 42 are both multiples of 3, so I'm going to take out a 3. Then you look 6x plus 1 to the 7th and the 6th, so we take out to the 6th. 3x minus 4 to the 14th and the 15th, so we take out to the 14th. And then parentheses, see what's left. So we took out a 3 from 45, so that's 15, and there's still a 6x plus 1. We took out a 3 from 42, so that's going to be 14, and it's minus, so minus 14. And then there's still a 3x minus 4. And that's all over still. Just 6x plus 1 to the 14th. I'm not touching that yet. Okay, so let's see what we can simplify here. So y prime. That 3 is just going to stay there. We have a 6x plus 1 to the 6th in the numerator and a 6x plus 1 to the 14th in the denominator. So there's more of them in the denominator, so I'm actually just going to cancel all of it from the numerator, so I'm just getting rid of that at this point. So there's still a quantity 3x minus 4 to the 14th. When you simplify everything that's in that third set of parentheses in the numerator there, you end up with just the quantity 48x plus 71, kind of an algebra 1 problem. And then divided by, so we canceled 6x plus 1 to the 6th. So we just are left with the quantity 6x plus 1 to the 8th. And that's actually your final answer. Okay, let's do another one that looks kind of like the quotient rule. So here we go. So we have y equals the quantity 5x squared plus 1 to the 4th over the quantity 7x minus 6 to the 9th. I feel like I read that numerator very strangely, but what are you going to do? All right, let's do this. So it's bottom derivative of the top minus top derivative of the bottom all over the bottom squared. Going to be a bunch of chain rule and some factoring and some canceling, just like the last one. So y prime is equal to bottom derivative of the top. So there's going to be a 4 from the power rule, and then there's going to be a 10x from the derivative of the inner function. So 4 times 10x is 40x. Quantity 5x squared plus 1 to the 3rd, because we're basically using the power rule on that part. And then minus the top, which is 5x squared plus 1 to the 4th. Derivative of the bottom is, there's a 9 from the power rule and a 7 from the derivative of the inner function. 9 times 7 is 63. And then quantity 7x minus 6 to the 8th. And then all of this is over the bottom squared, so we go from the 9th power to the 18th power. And then we're going to look just at the numerator. There's factoring we can do, and then some simplifying and some canceling. So y prime is equal to, okay, so 40 and 63 do not have any common factors, so we're not going to factor anything out of that. I see 7x minus 6 to the 9th and the 8th, so take out to the 8th. I see a 5x squared plus 1 to the 3rd and the 4th, so we take out to the 3rd. So now we're going to have parentheses, and we see what's left. So 40x is still there, and then a 7x minus 6 is still there, and then minus 63 stays, and then a 5x squared plus 1. 5x squared plus 1 stays. Okay, and then all of that. You can see the 7x minus 6 is definitely going to cancel. We have it to the 8th in the numerator and to the 18th in the denominator, so that'll cancel and just be in the denominator. So I'm going to cancel that. So I'm going to start this with quantity 5x squared plus 1 cubed. If you expand everything in that third set of parentheses there, you actually end up with negative 35x squared minus 240x minus 63. Everything has a negative, so like you might choose to take out a negative. I think most people would do that, but I'm not going to bother in this case. And then all over, so remember we had 7x minus 6 to the 8th over 7x minus 6 to the 18th, which leaves us with 7x minus 6 to the 10th. All right, so that's another quotient rule problem. So I'm going to stop here, do some more, and then come back and finish this video, I think. So I'm going to pause my recording, but that's kind of irrelevant to you. Okay, let's take a look at this one. So this actually has kind of three functions, I suppose. So we have y equals the square root of 7 plus the quantity 8x minus 5 to the 6th. So I tried to color code them. So square root function is like the first function, and then the inner function is 7 plus something to the 6th, and then the third function is 8x minus 5. So it's just going to be a bunch of chain rule. First thing I'm going to do is rewrite this, because radicals can be difficult to work with. So I'm going to rewrite that square root as just a 1/2 power, so rational exponents are a little easier. And now what I'm going to do is chain rule. So I have something to the 1/2, so it's going to be 1/2, and then it's that thing, which is this stuff, to the 1/2 minus 1 is negative 1/2. Okay, so that's the first part of our chain rule. Then we have to multiply by the derivative of the inner function. So the inner function is 7 plus something to the 6. So the derivative of 7 plus something to the 6 is, the derivative of 7 is 0. And then something to the 6th is going to be 6 times that thing to the 5th, and then times the derivative of that thing. And so the final inner function is 8x minus 5. The derivative of that is 8. And then you might want to clean it up. So you have a 1/2, a 6, and an 8. So that's 1/2 of 48, so 24. So 24. And then that 8x minus 5 to the 5th is still there. And then all over, because I'm not going to leave the negative exponent, although there's really nothing wrong with that. It just depends on what you're going to do with it. So all over, I'm going to say it's this. So the square root of 7 plus the quantity 8x minus 5 to the 6th. So I dropped that down, I turned it back into a radical. You could have left it as a rational exponent, but that's the final simplified answer. All right, let's take a look at one more. So here we have the cube root of the quantity 5x plus 1 to the 7th plus the quantity 4x minus 3 to the 6th. Okay, so it's just going to be chain rule. It's kind of the whole point. So I'm not even going to bother rewriting this one as a rational exponent. It's just to the 1/3. I'm thinking of that in my head. So it's going to bring down the 1/3, and then the quantity, everything that's inside that radical there. So we have this. And then it's 1/3 minus 1 is negative 2/3. And then times, now we need to multiply by the derivative of this inner function. So it's going to be two separate chain rules. So for the first part, I'm going to bring the 7 down and multiply by 5, because that's the derivative of the inner function. So 7 times 5 is 35. And then we still have 5x plus 1 to the 7 minus 1 is 6. And it's a sum, so I don't need to do a product rule or quotient rule. I can just write plus. So I'm going to bring the 6 down, multiply by 4, because that's the derivative of the inner function. So 6 times 4 is 24. And then I still have the quantity 4x minus 3 to the 6 minus 1 is 5. Okay, and then this really doesn't simplify very much. I'm going to rewrite it anyway for you. So it's 35, the quantity 5x plus 1 to the 6th, plus 24, the quantity 4x minus 3 to the 5th, all over 3, and then all that stuff to the 2/3. All right, so that's 10 pretty good chain rule problems. I hope you found this helpful, and good luck.